How to solve rational equations. The easiest way to solve a rational equation is by doing the following technique that I have highlighted here, and it is to multiply both sides of the equation by the LCD of all the fractions or rational expressions that appear in the equation. And that what this will do is it will get rid of all the fractions. It will get rid of all the rational expressions, and you will not have any more fractions whatsoever. You will not have any more rational expressions, and then the equation will be something that will be easier to solve. It will be either a linear equation or a quadratic equation or any other polynomial equation. There is one more thing though that is important when solving rational equations, and it is that we must always check to see if our answer is part of the domain. And what that means is that we have to check that we can actually plug in the answer in the original equation. So the answer makes sense in the original equation. And that basically means check that you're not divided by 0 when you plug in your answer in the original equation. Because you cannot divide by 0. If you get a number that makes any of the original fractions or rational expressions 0 on the bottom, on the denominator, then that means that's not a true answer. You have to discard it. Okay. All right, so let's start with this one. It says solve the following equations. The first one says x over 4 minus quantity x minus 3 over quantity 5 equals x over 2 minus 3. All right, so first thing we need to do is find the LCD of all these fractions that we have here. So what is the LCD of 4, 5, and 2? The LCD of 4, 5, or the least common multiple, I have to think of the smallest number that contains all of them as a factor. That seems to be 20. 20 is the smallest number that has 4, 5, and 2 as a factor. Okay. Remember though how you actually do this. You're supposed to factor each of the denominators. So 4 is 2 squared, and then 5 is, we cannot really factor that, and then the other one is 2. You cannot really factor that either. And then the LCD is going to be, you write all the different factors, 2 and 5, and then you always choose the biggest of the exponents. So it should be 2 squared. And if you multiply 2 squared times 5, you do get 20. Okay? Okay, so then we're going to multiply everything in that equation by 20. Everything gets multiplied by 20. So everything on both the left and on the right. Multiply the whole equation by 20. So I'm going to write it like this. 20 times x over 4 minus 20 times x minus 3 over 4 equals 20 times x over 2 minus 3 times 20. Okay, so I multiplied every single term by 20. Normally, when you have multiple terms in the numerator like that, you might want to put parentheses because it might confuse you, make you make a mistake. All right, so now let's simplify this. If you cancel 20 divided by 4, that's going to be a 5. And, oh, that should have been a 5. That's a typo. That's a mistake. I copied that wrong. Okay, that's a 5. Okay, good. Now, 20 divided by 5, that's a 4. And then 20 divided by 2, you get a 10. And that's it. Okay, let's write down what we have. We have 5x minus 4, parentheses x minus 3 equals 10x minus 16. Okay, now you have this equation that you see has no fractions, no rational expression, so it should be easy to solve. So let's solve it. This is going to be 5x distributing minus 4x plus 12 equals 10x minus 60. Combining these x's over here, you get x plus 12 equals 10x minus 60. Now moving things around, let's say you move the x's. Let me move this x over here, and the 60 over there. Doesn't really matter, but I'm going to move the 60 over here, and I'm going to move the x over there. So what do we get? We're going to get 60 plus 12 equals 10x minus x 10x minus x, which is 9x. And then this is 72, and then dividing by 9, we're going to get that x equals 8. Okay? Once you find your value of x, remember that you should make sure that this value of x does not make any of the fractions have a 0 on the denominator. So if you look, plugging in x is not going to make any of those bottoms or denominators equal to 0. So that's it. As long as there's no mistakes, that should be the correct answer. Okay. Now let's do another one. Now with variables in the denominator. Okay. First thing is find the LCD. So you have to factor each of the denominators. X plus 2 does not really factor anymore. And then 2x is 2 times x, so it has 2 factors. So the LCD is, you write all the different factors. So 2x, x plus 2, and then if there were any exponents, you pick the biggest one for that factor. But that's it, we don't have any exponents. Alright, so if that is the LCD, then we're going to multiply everything in the equation by this. Every single term on both sides. So this is going to look like this. 2x, x plus 2 times x plus 4 over x plus 2 minus 2x, x plus 2 times 1 equals 3 over 2x times 2x, x plus 2. Alright, so everything gets multiplied by the LCD. And then you may cancel things. So that cancels. There's nothing here to cancel. And that 2x and that 2x cancels. And then you write down what is left. So here you have left 2x, x plus 4 minus 2x, x plus 2 equals, that cancels, and you're left with 3x plus 2. Okay, now let's simplify this. Distribute, so that's going to be 2x squared plus 8x minus 2x squared minus 4x equals 3x plus 6. Now collecting like terms, these 2x squared minus 2x squared cancel each other off, so that means there's not going to be any square terms. There's not going to be any quadratic terms. And then 8x minus 4x is 4x. So 4x equals 3x plus 6. Move the 3x to the left. So you're going to have 4x minus 3x equals 6. and that gives you x equals 6. Okay? Once you find x, you have to make sure that it doesn't make any of the fractions have a 0 on bottom when you plug it in. If I plug in 6, x equals 6 here, the bottom becomes 8 here, which is good, it's fine, that's not 0. And here it would become 12, okay? So none of the denominators become 0, so that means it's good. That's, as long as there's no mistakes, that's the correct solution to this equation. Okay, let's do another example. Here we have it. First step, as usual, is going to be find the LCD. So you need to start by factoring each of the denominators. The very first one does not really factor, just itself. And the second one does not really factor either, so do nothing. The third one does factor because it is actually a difference of squares. 4x squared is the square of 2x, and 9 is the square of 3. So using the difference of squares formula, this is 2x minus 3 to x plus 3. And now that everything has been factored, we can write down what is the LCD. The LCD is you look at the different factors, 2x plus 3, 2x minus 3. They're repeated here. You only write them once. So you write those, and then if there's any exponents other than 1 for either of the factors, you choose the biggest one. In this case, there's none, so that means that's it. That is the LCD. Okay, now you use the LCD to multiply both sides of the original equation by that. So I'm going to multiply both sides by this. So I'm going to write 2x minus 3, 2x plus 3. So I use that to multiply the left-hand side by this. I'm writing it like this because if I were to write it twice, one for each of the factors like I did in the previous one, it will not fit on the page. So I'm just writing it once, and then we know we have to distribute, and we'll do it that way because otherwise it's not going to fit. Okay, and then you multiply also the right hand side by the LCD. So 2x minus 3, 2x plus 3. Okay, so that's what we have. Now we're going to distribute this. If I multiply this by that, note that the 2x plus 3 would cancel. The 2x plus 3 would cancel, and you would be left with the 2x minus 3 and the 5. So distributing, that's what you get for the first one. You get the 5 and the 2x minus 3 left after canceling. And you're going to have to do that visually because you don't want to mess that up. You're going to then you're going to also distribute this thing with that one. Now, visualize that if you multiply this by that, you can block that one out of view if you want. Just cover it up. If you multiply that by that, the 2x minus 3 would cancel, and you'll be left with 4 and 2x plus 3, okay, because the 2x minus 3 would cancel. So you're left with 4 and 2x plus 3. All right, and then on the right-hand side, note that 4x squared minus 9 is actually exactly equal to this, to both of them. So that means if you were to write this in factored form, instead of like this, both of them would be down there, so both of them would cancel. So the whole thing would cancel. All right, so then that means you're left on the right hand side with just 14x plus 3. Alright, now let's continue. Distributing here, this would be 10x minus 15. Distributed here, you would have 8x plus 12. This is 14x plus 3. Combining the x's like terms on the left hand side, we would have 10x plus 8x is 18x. Negative 15 plus 12 is minus 3. Negative 3 equals 14x plus 3. Then moving things around, moving all the x's to the left hand side, you would get 18x minus 14x, and then moving the 3 over, you would have 3 plus 3 on the right hand side. And then simplifying, this is 4x equals 6. And then dividing by 4, this means that x equals 6 over 4. What is 6 over 4? 6 over 4 is 3 halves. Dividing by 2 top and bottom. So that means, let me write it down here, that x equals 3 halves. Okay, so we got that x equals 3 halves. And now, don't forget that once you find your values for x, you have to go back and see whether they make any of the bottoms, any of the denominators equal to 0. So we have 3 halves, and you may use the calculator for this. If you plug in 3 halves here, you would get 6. If you plug in 3 halves here, you would get 0. Actually, you will get 0 on bottom here. If you plug in 3 halves, look at that, you can do it by hand. 2x minus 3, if I replace the x with 3 halves, we get 2, 3 halves minus 3. The 2's would cancel, and you would get 3 minus 3 equals 0. So, no, that's bad. That makes the bottom 0 on the original equation. So that means this is not part of the domain. And if it is not part of the domain, this has to be discarded. Okay, not part of the domain. Therefore, it needs to be discarded. Conclusion: if you only had one solution and you discard that one, then you have nothing. That means there are no solutions. Sometimes you have, sometimes you end up with 2 or 3 solutions and only one of them doesn't work. Or you may end up with 2 and one of them doesn't work. Sometimes it could happen that you have 2 and none of them work still, because they make denominators equal to 0. So you really have to check all of them, each and every one of them. Okay, so there are no solutions. You need to discard that, and I'm gonna cross it out in red. That does not work. Okay, well, now we're gonna do one more example. You should pause the video for the next one and attempt it on your own and see whether you get the right answer. And don't forget to double check your work. Okay, here it is. So give it a shot. Okay, let's do it. Before I begin this problem, one thing that I should mention is that there's a point that I haven't been emphasizing, but that you should really make a note of it and keep it in mind. In all these problems of solving rational equations, one thing you should always try to watch out for is to see if there's any simplification you could do before you begin the actual process of solving it. So see if there's anything that you could do, if any little simplification. If you can simplify a little bit, that is something that you should really do, first of all, because sometimes if you don't do that initial simplification at the beginning, it could lead to a very complicated thing at the end. So in all these problems that I've been doing, none of that is required. I mean, none of that has been needed because there has been nothing really to simplify. But in some of the homework problems, it could happen that you should do a little bit of simplification first before you actually start the problem. Okay, so even though I don't mention it, make a note of that. That's how you should really start all of these problems. See if there's any little simplification you could do. Okay, in this problem, there's really nothing to simplify. You cannot really factor that anymore. The bottom you could factor, but then if you factor it, you cannot cancel with the m minus 5. So there's really nothing to simplify here. Okay, so now that I know there's nothing to simplify, let's begin with the actual procedure, which is find the LCD. Okay, to find the LCD, you factor every single denominator that you see. M minus 1 cannot be factored anymore. And m squared minus 1 is a difference of squares. So this factors as m minus 1, m plus 1. All right, now we can write down what is the LCD. The LCD is, write the different factors that popped up, the m minus 1 and the m plus 1. And if there were any exponents, you pick the highest. There's no exponents here, so that's it. So this is our LCD, m minus 1, m plus 1. Okay, now that we have the LCD, we multiply both sides of the equation by the LCD, and that should get rid of all the fractions. Okay, so I'm going to copy the left-hand side, and we're going to multiply this by the LCD. Okay, you could use parentheses or brackets, doesn't matter. Same thing. Okay, so multiply the left-hand side by that. And also the right-hand side, which is just 1 in the original equation, multiply by the LCD. Okay, so this is what we have. Now, distribute, multiply. Note that if I were to multiply this by that, the m minus 1 would cancel. So if I cancel the m minus 1, what is left is 2m m minus 1, m plus 1, right? If I cancel that, I'm left with 2m and the m plus 1. And then when I distribute here and I multiply that by this, the bottom is actually the unfactored form of that. So m squared minus 1 is actually both of the terms. So that means I could cancel both of them. And if I cancel both of them, what I'm left with is m minus 5. Alright, now on the right hand side, the 1 doesn't really do anything, so you can ignore it. And then multiply that out. We're going to FOIL it out. If you FOIL that out, you will get m squared minus 1. That's actually just a difference of squares formula backwards. But if you FOIL that out, you get m squared minus 1. Okay, now we have a quadratic, and we're going to solve this. Distribute here, so you're going to get 2m squared plus 2m. And then here, m minus 5 equals m squared minus 1. Then collect any like terms. So this is 2m squared plus 3m minus 5 equals m squared minus 1. Now move everything to one side because you can need 0 on the other side. So moving the m squared, I will get minus m squared. So 2m squared minus m squared is m squared. You have plus 3m. And then moving the minus 1, it becomes plus 1 when you move it. So you would have negative 5 plus 1. Negative 5 plus 1 is negative 4. So minus 4. And now you solve that any way you want. You can use a quadratic formula or you could factor different factors. So that's what I'm going to do. That would be m plus 4 m minus 1, and then set each of the factors equal to 0, you get m plus 4 equals 0, or m minus 1 equals 0. And lastly, solve each of the resulting equations. This one gives us x equals -4, and this one gives us m equals 1. Okay, so those are the two solutions that we found. Okay, now we should not forget that for rational equations, we have to check whether our answers make any sense. We need to check whether they make any of the denominators equal to 0. So let's start by checking m equals 1. Go back to the original equation and see if it makes any of the bottoms equal to 0. And indeed, if I plug in m equals 1 here, that denominator would be 0. So that means this number, this solution is not good. Right? This solution is not good. This is not a solution. It makes one of the denominators equal to 0. So this is not a solution. We sometimes say that by writing it is not part of the domain. Okay, now check the other one. M equals -4. Check the denominator, see if any of them becomes 0 when you plug it in. If I plug in m equals -4, -4 minus 1 is actually -5, so that's no problem. If I plug in -4 in the second one, -4 squared, that would be +16. +16 minus 1 is 15. So the second denominator is not 0 either after I plug in. So that means m equals -4 is good. That is a solution. There's nothing else to say, but there's one pro tip though. There's one pro tip that I like always mentioning, and here's the pro tip. When the rational equation has only two fractions, two rational expressions, so unlike this one, you see this one has three terms. So I meant two terms. So this one has three terms, 1, 2, and 3. And then the other one that we did has three terms, 1, 2, and 3. So if your rational equation happens to have only two terms, like this one, 1 and 2, then there's actually a slightly easier method where you don't have to bother with finding the LCD, with factoring, finding the LCD. So when there's only two terms like that, one fraction equal to another, or one rational expression equal to another, you don't have to think about the LCD, just cross multiply and set the expressions equal to each other. That's the easiest thing to do. You would be saving that LCD step. So for example, I have only two terms here, two equations equal to each other, so you just cross multiply. Cross multiplying means that 2 times 5x squared minus 6, so that times that equals that times that, equals 2x plus 3 times 5x plus 3. Alright, and you see, I immediately got an equation that is a polynomial equation. I didn't have to bother with LCD. So just keep that in mind. Whenever you have two terms, this is always the easiest thing to do. So then let's continue. This is going to be 10x squared distributed minus 12. And now let's FOIL this. This is 10x squared plus 15x here plus 6x over there plus 9. Okay, move everything to the same side. The 10x squared is actually going to cancel when you move it to the other side. You're going to have 10x squared minus 10x squared, so they're going to cancel each other off. And then what you have a negative 12, and then what's that? That's 21x plus 9. Now let's move the 9 That would be negative 21 equals 21x. Okay, negative 12 minus 9 is negative 21. So I move the 9 to the other side. And then um, divide by 21 to get the x. And you're going to get that x equals negative 1. Okay, don't forget to check whether this answer is in the domain or not. Alright, if you plug it in the bottom of the first fraction, you get, I'm plugging in negative 1, you will get 2 times negative 1, that's negative 2 plus 3. Negative 2 plus 3 is positive 1, is not 0, so no problem. And in the next one, if you plug in negative 1, you're going to get negative 1 squared is positive 1 times 5 is positive 5 minus 6 is negative 1. So the second one doesn't become a 0 on the denominator either. So no problem whatsoever. That means that is the solution. Okay, now let's apply that same trick here to do it one more time. So again, I have only two terms. I won't bother with LCD because that's not necessary. Just cross multiply. If you cross multiply, you're going to get x times 4x minus 2 equals 2x times 2x minus 1. What happens here? Then you're going to get 4x squared minus 2x equals 4x squared minus 2x. Now move all the x's to the same side. You're going to get 4x squared minus 4x squared negative 2x plus 2x and combine like terms. And you see that you get 0 equals 0. Aha, what does that mean? When you get 0 equals 0. That means that basically all numbers work. All of them. With the exception, of course, of the ones that make the bottoms 0. So that means all real numbers, because this is always true, always. This is true always. 0 equals 0 is true always. So that means always any number is a solution, except when the original equation becomes 0 on the bottom. So all real numbers are solutions, except those that make either the first denominator equals 0 or the second denominator equals 0. But in this case, if you solve these two equations, you actually get the same thing. What do you get? You get that x equals a half. So if you solve this one, you get a half. If you solve that one, you get a half. So that means all real numbers except this one. So all real numbers x such that x is not half. That's the solution, right? All real numbers that are different from a half, in this case. Now, another thing that could happen, so in this case you get like 0 equals 0, that's a true statement always, so it means every single real number is a solution except the obvious one that need to be discarded. If you happen to get something like that is something that is always false, such as 1 equals 15, in that case, since that is always false, that would mean that there's no solution whatsoever. No solution. If you get something that is always false, that means there's no solution. If you get something that is always true, that means every number is a solution except the ones that need to be discarded, because you cannot divide by 0. Right? And that's all.